Hi everyone, this is Dr. Ramanna, Assistant Professor of Physics. Today I am going to talk about the relation between electric displacement, electric field, and electric polarization. And the electric displacement is denoted by D, electric field is denoted by E, and electric polarization is denoted by P. Before going to that, just I want to tell what is electric displacement. See, first, we should consider a charged spherical conductor of radius r, this is a capital R, and which is enclosed by a charge q. First, we should consider a spherical conductor and its radius is r and which is enclosed by a charge q. Now, how to find the electric intensity at any point on the surface? And it is given by E equal to q divided by 4 pi epsilon naught r square. We know that E equal to what? We can write force per unit charge. Okay, so according to Coulomb's law, we can write F equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square. Okay, so the whole divided by q. Q get cancel and the remaining is E equal to q divided by 4 pi epsilon naught r square. Okay, so that's what we have written here, E equal to q divided by 4 pi epsilon naught r square. Now epsilon naught comes to this left side, that is epsilon naught into E equal to q divided by 4 pi r square. Now we can write this equation as epsilon naught into E equal to q divided by A, because A is what? Area, surface area of the spherical conductor. Okay, so that is what? That is 4 pi r square. So instead of 4 pi r square, I will write A. So the now equation becomes epsilon naught into E equal to what? Q divided by A. So now D equal to, I can write D equal to Q divided by A. Okay, charge per unit area. Charge per area. So where D is called electric displacement and it can be defined as the product of electric field and the permittivity of free space, that is epsilon naught into E equal to D. Now comes to the relation between D, E and P. See, here we have to consider first two parallel plate capacitors having positively charged and negatively charged, that is plus Q and minus Q. In between these two parallel plate capacitors, we have to keep a dielectric material. When we apply an electric field to this, okay, so the molecules which are in the dielectric materials get separated. The polarization will happen inside the material. So thereafter, the positive charge goes to negative plates and negative charge goes to positive plates. So those charges are what? Those are induced charge, that is minus q dash and plus q dash. Plus q and minus q are free charges which are on capacitor plates. Minus q dash and plus q dash are induced charges. It happens after polarizations. Okay. See, now what is the resultant field between the parallel plates of the capacitor in presence of electric field? Okay. So, the resultant field between the parallel plates of the two capacitors is equal to E equal to Q minus Q dash divided by epsilon naught into A. See, the total charge on the capacitor plates, that is Q minus Q dash. Okay, so divided by epsilon naught into A. So epsilon naught comes to the left side, that is epsilon naught into E equal to Q minus Q dash divided by A. So now the equation becomes epsilon naught into E equal to, so we can write this equation as Q divided by A minus Q dash divided by A. Okay, see, this q divided by A comes to the left side. Okay, so now the equation becomes epsilon naught into E plus q dash divided by A. So here I will write q dash divided by A equal to P, because induced charge per unit area of the dielectric. How we can define the polarization? So induced charge per unit area of a dielectric. Okay, so A be the surface area of the dielectric slab. Okay, so q dash divided by A equal to what? P. P is polarization. So therefore, now equation becomes q divided by A equal to epsilon naught into E plus P, where D equal to what? Q divided by A. So in the above equations, D, E and P are vectors. So what is the note over here? So D is connected with free charge only. Is connected with polarization charge only, and E is connected with all the charges, that is the resultant field. In isotropic media, P and E are in the same direction, but in non-isotropic media, P and E are in different directions. So here he is reduced inside the dielectric. Okay, thank you.